All right, welcome to The Explainer. Today, we're stepping into the shoes of a network architect. Think of these guides as our map. We're going to design a network that's not just up and running, but truly resilient. I mean, it's the question that probably keeps every network admin up at night, right? And the answer? Well, it turns out it's about way more than just knowing a few commands. So to get there, we're going to lean on two key resources. You've got your high-level design guide, that's for the big picture, the why, and then you've got your detailed command line reference for the nitty-gritty, the how. And when you put them together, that's the complete journey of a network architect. All right, let's get into it. First, we'll talk about designing the modern LAN. Then we'll cover fortifying the network edge. After that, we'll translate theory into practice with some commands. Then we'll look at ensuring constant availability. And finally, we'll wrap up with a look at the future-proof network. You know, every great structure, a skyscraper, a bridge, whatever, it starts with a solid blueprint. And a network, it's absolutely no different. So think about it. Modern networks are just these incredibly complex ecosystems, right? Devices, users, apps. So how in the world do you manage all that? Well, you need a structured approach. And that brings us to a classic, proven model that really works. It's this three-layer hierarchical model. And honestly, the best way to think about it is like a city's road system. You've got your access layer. Those are the local streets connecting houses. Then the distribution layer, kind of like the main roads that gather all that traffic. And finally, the core layer. That's your high-speed highway, the backbone of it all. And the really cool thing is, this isn't just some abstract theory from a textbook. There are documents out there, like these Cisco-validated designs, that literally give you a framework. They lay out the proven, tested, best practices that you can actually follow. Okay, so we've got our blueprint. Now what? Well, now it's time to build the walls, right? We gotta fortify the network edge and protect it from some really common but really dangerous threats. So first up is something called DHCP snooping. And you can pretty much think of it as your network's gatekeeper. Its entire job is to stand at the door and stop rogue DHCP servers from coming in and hijacking your traffic by handing out bogus IP addresses. And then there's dynamic ARP inspection, or DII. This is what stops those nasty man-in-the-middle attacks. But what's so clever, and what you really need to get, is how these two features are a team. DII literally uses the list of good guys, the database, the DHCP snooping built. It's a fantastic 1-2 punch. Okay, so that's the theory, but how do we actually do it? This is where we translate that security concept into real-world action. And you can see right here, different vendors, Aruba, Cisco, they might use slightly different commands, but the end goal is exactly the same. But look, DAI isn't the only tool we have. It's just one piece of a much bigger security arsenal. You've got things like 802.1x authentication, IP source guard, port security. The list goes on. Each one of these adds another crucial layer of defense to that really vulnerable access layer. Okay, let's get our hands dirty. We're going to jump over to the command line now and see how all this theory actually looks in practice. This is also a great way to see how different vendor ecosystems work. Okay, so take a look at this. On the left, you've got Aruba OS switch. On the right, Cisco iOS. Yeah, the syntax is a little different, right? But the core concept, what we're actually trying to do, assigning a specific port to a VLAN, that is 100% identical. And here we go again. Another perfect example with a standard access control list. The phrasing is a bit different, sure, but the logic, it is exactly the same. Deny this one specific host, and then permit everything else. The underlying principle is universal. All right, let's be real. A network that isn't available is pretty much useless, right? So let's talk about the safety net. How do we build in resilience to prevent that dreaded downtime? This brings us to one of my favorite concepts, switch stacking. The idea is simple but so powerful. Multiple switches, one brain. You take a whole stack of physical switches and make them act like one single unified system. It's a brilliant way to simplify management and, more importantly, create a seriously redundant setup. So how does it work? Well, if that primary active switch in the stack fails, a standby switch takes over almost instantly. And the magic that makes this happen are technologies like Cisco's StackWise and Stateful Switchover. They make the whole failover process so fast, it's practically seamless. So what's the goal of all this? It's to hit that magic number, 99.999% availability. We call it 5 nines. And to put that in perspective, that means less than 6 minutes of downtime for the entire year. That's incredible. And technologies like stacking are absolutely key to even getting close to a number like that. Okay, so we've done it. We have a robust and secure network that's ready for today. But the job isn't done. The final and maybe most critical step for any great architect is to think about tomorrow. You see, the industry is always moving forward. We're heading towards more automated, policy-driven networking. You'll hear terms like software-defined access. But here's the thing. This next evolution, it doesn't replace the fundamentals. It builds right on top of the solid design principles we've just covered. And that really gets to the heart of what it means to be a network architect. It's not just about what commands you know, it's about why you're using them. Because if you truly understand the architectural why, you can walk into any environment with any vendor's gear and figure out the how. You become adaptable. So I'll leave you with this question. Your network might be built for today's needs, but is it designed for tomorrow's? Answering that, well, that's what separates a network operator from a true network architect. Thanks for joining us.